GeopByte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. The speed of a swimmer in still water is 20 meter per second, whereas the speed of the river water is 10 meter per second and is flowing due east. It is like this. This is the river. Given that river water is flowing in this direction, this is the river water flow, river water flow towards east. Okay, the river water flow velocity is given 10 meter per second. Okay, whereas swimmer is maintaining 20 meter per second. Okay, then if he is standing on the south bank, this is the south bank, and wishes to cross the river along the shortest path. He wants to cross the river, right, along the shortest path, means towards the north bank. The angle at which he should make his strokes with respect to the north is given by. That means for reaching to north bank in the shortest path, he must be swimming towards west. He must be swimming towards west. It is like this. Then this is the swimmer velocity. This is the river water velocity. This is the right angle between the river water flow and swimmer to reach the other bank in the shortest path. Then that theta equal to, sine theta. Look at the diagram. Sine theta is opposite side by hypotenuse. Opposite side is 10, hypotenuse 20, 10 by 20, 1 by 2. Therefore, theta equal to sine inverse. Sine inverse 1 by 2. Sine inverse 1 by 2 means 30 degrees. Okay. So, he has to, right, move towards the west at an angle, right, at 30 degrees. South of west, right. Option A is absolutely correct. Understood clearly? Similarly, look at the another important problem asking like this. A particle standing from rest moves in a circle of radius r. A particle starting from rest means initial angular velocity omega naught equal to 0, and it is circulating with radius of rotation r, attains a velocity of v naught meter per second. That means final angular velocity equal to v naught by r in the nth round. Nth round means angular displacement theta equal to 2 pi n. Then its angular speed will be very simple problem. As you know, v square minus u square is equal to 2a s. That is for linear motion. This is for linear motion. Whereas for angular motion, omega square minus omega naught square equal to 2 into alpha into theta. Okay, alpha be the angular acceleration. Here this omega naught equal to 0. Finally, omega square equal to 2 alpha into theta. From this, alpha equal to omega square by 2 theta. Look at the omega. Omega equal to v naught by r whole square divided by 2 into theta 2 pi n. Simplify this value. It is equal to v naught square by, it is 4 pi r square n. Look at the options. V naught square by 4 pi n r square. Look at the option C. Option C is absolutely correct. Since it is angular acceleration, its units is radians per second square. Understood clearly? Yes. Then similarly, let us take the another important problem. It is asking like this. Two particles A and B are moving in uniform circular motion in concentric circles of radius RA and RB with speeds VA and VB respectively. It is like this. Two particles are moving in the forms concentric circles with the radius of rotation. This is the radius of circular motion maintained by the particle A with a velocity VA, and this is the radius of the particle B moving with a velocity VB. Okay. Then their time period of rotation is same. The time period of A equal to time period of the B. Then the ratio of angular speed of A to that of B is. You are asked to decide what is the angular speed of A divided by angular speed of B. Oh, how much? Since TA equal TB, TA by TB is how much? TA by TB equal to 1. Then omega A by omega B must be equal to TA by TB, that is equal to 1. Therefore, omega A is to omega B is equal to 1 is to 1. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. Two stones of masses m and 2m are whirled in horizontal circles. The heavier one in radius of r by 2 and the lighter one in radius r. The tangential speed of the lighter stone is n times that of the tangential speed of the heavier stone. They are reported to experience the same centripetal force, then the value of n is. There are two stones, stone 1 and stone 2. Given stone 1 mass is m1 equal to m, stone 2 mass is m2 equal to 2m, and the heavier mass radius r by 2, that means r2 equal to r by 2, whereas the lighter one r1 equal to r. The tangential speed of lighter stone is n times that of the tangential speed. That means the V1 equal to n times the V2, where V2 be the velocity of the stone 2. But it is given that both are maintaining the same centripetal force. That means FC1 equal to centripetal force for the first one equal to centripetal force for the second one. Then what is the value of n? N equal to how much? This n is how much? Okay, for that, as you know, centripetal force equal to mv square by centripetal force Fc equal to mv square by r. Then I can write m1 v1 square by r1 equal to m2 v2 square by r2. Now let us substitute the values. m1 equal to m v1 equal to n v2 whole square divided by r1 is given r equal to m2 2m v2 square divided by r2 equal to r by 2. Now let us simplify it. Let us take another slide. Here it is m n v2 whole square divided by r equal to this 2 goes up 4m v2 square 4m v2 square divided by r Now here this r cancelled, m is cancelled, n square v2 square is equal to 4 v2 square. v2 square is cancelling, n square equal to 4, therefore n equal to 2. Therefore, I can say that V1 equal to N V2. No? So N equal to 2 V2. Look at the options. Option D is absolutely correct. Understood clearly? Yes.
GeopByte.